Everyone, myself prachalith, lecturer in physics, Kotturu College, Kotturu. In my today's session, I am discussing about a production of low temperature by the adiabatic demagnetization. Here, when the paramagnetic substances is magnetized, then external work is done on it and the substance is going to increase its temperature. But on the other hand, when the substance is adiabatically demagnetized, work is done by the substances and its temperature falls down. This effect we can call it as a magnetocaloric effect. Here, overall our motto is to attain a low temperature by the process of adiabatic demagnetization. And here, a maximum cooling can be obtained by employing a strong magnetic field and a low initial temperature. In this process of adiabatic demagnetization, we have to follow two main challenges, that is in order to maintain a strong magnetic field and attaining a low initial temperature. See here, this experimental arrangement is consisting of three double-walled device flask, that is D1, D2 and D3, and you can observe in this diagram, and where the D1 consists of a liquid air and D2 is having a liquid hydrogen and D3 is consisting of a liquid helium, and the tube D contains a paramagnetic salt, a paramagnetic substance in the form of a spherical or ellipsoidal shape, and it also contained with some helium gas in order to maintain a contact in between the other flasks and to that particular paramagnetic substance. Here initially whole this setup is kept inside in between the two strong magnetic fields. Then here what is happening, initially this paramagnetic substance is maintained at a particular temperature. It is maintained at a particular temperature. Then a strong magnetic field is applied, about a 3 Tesla magnetic field is applied to that particular paramagnetic substance. Then what happens, because of this strong magnetic field, the paramagnetic substance, it is going to increase its temperature. It's going to increase its temperature. The paramagnetic substance which is contained in the tube A, you can see here in the tube A, it is going to increase its temperature by using a strong magnetic field. Then a cold helium gas which is surrounding around that particular tube A is pumped out in order to maintain a constant temperature for that particular paramagnetic substance. Then what happens, that paramagnetic substance, when it is the temperature is increasing because of the external strong magnetic field, and because of the liquid, the hydrogen liquid and helium liquid which is covered around that particular paramagnetic substance is maintaining its temperature constant, a low temperature. Then after some time, the paramagnetic substance is going to decrease its temperature because of those liquid air, liquid helium and liquid hydrogen surrounded by it. So then after, at maintaining a constant low temperature of that particular paramagnetic substances, that strong magnetic field is made to switch off. That strong magnetic field which is given to that particular paramagnetic substances is removed. Then what happens, it is nothing but that paramagnetic substance is adiabatically demagnetized. We know that the adiabatic process is nothing but a constant temperature. There must be, if inside the closed system, there will be a constant temperature. And here also, that paramagnetic substance is attaining initial low temperature, and with that initial low temperature, by keeping that initial low temperature constant, this magnets are removed. This magnetic field is removed for that particular paramagnetic substance. Then what happens? If we remove the external strong magnetic field from that paramagnetic substances, then what happens? The work is done by the substances and its temperature is falling down. Already a paramagnetic substance has initial low temperature. It is having a low initial temperature because of an external liquids surrounded surrounded. Okay, that is a liquid air, helium, and a hydrogen. Because those liquids are attained, those liquids are making the paramagnetic substance to attain the low temperature already, and along with that, by adiabatic demagnetization, in the sense by keeping that initial temperature constant, that the magnetic field is, that strong magnetic field is removed out of the paramagnetic substance, and hence that particular paramagnetic substance which is present inside the tube A is attaining a very a low temperature, very low temperature. This is how we can produce the low temperature by the an adiabatic demagnetization process. Then, according to Curie's law, the susceptibility of that particular paramagnetic substance, the susceptibility of that paramagnetic substance is inversely proportional to an absolute temperature, where we can say that is a chi is proportional to 1 divided by T. Then that will be equal to constant here. The susceptibility of a specimen at an initial and final temperature T1 and T2 respectively, and then reduce the final temperature will be then the reduced final temperature, and this reduced final temperature is nothing but what we have attained the low temperature by the process of adiabatic demagnetization. This is what the temperature attained by the process of adiabatic demagnetization. Okay, this is how this is all about the production of low temperature by an adiabatic demagnetization. Thank you.